So today we are going to be looking at some problems similar to what we have been seeing. We're still going to be looking at transformations, but specifically we're going to be looking at transformations related to quadratic functions and absolute value functions. Which basically means that our problems are going to look a little bit different than we've seen before, but I'm still asking for the same things that we've been seeing. I'm still going to be asking you to identify all of the transformations, but the way the problem is presented is going to be a little bit different. The reason that we're talking about this right now is because the next unit is going to be entirely about quadratic functions. Everything that we're doing in the next unit is going to be graphing quadratic functions. And these transformations that we are looking at in this unit and today are going to help us with the graphs of those quadratic functions in the next unit here. Before we get into the actual problems, I do want to give you sort of a brief definition for what a quadratic function is and what an absolute value function is. A quadratic function is any function where the variable is squared. Specifically, I should say that the highest power of the variable is a power of 2. So this would be something like f of x equals x to the power. I'm going to have to write that out by hand. So for instance, f of x equals x squared. This is a quadratic function. It's, in fact, our parent function. It's the most basic quadratic function that we can have. But any function where the highest exponent is a power of 2, the highest exponent for our variable is a power of 2, is considered to be a quadratic function. I could list off bunches and bunches of examples, but they're not incredibly important for what we're looking at today. We'll definitely see more in the future here. But one of the things that is important is the shape of the graph. The shape of a graph makes sort of a U shape, either opening up or opening down. And we'll talk more about that in the next unit. But I want to give you a little bit of a preview here. And we've seen this a little bit before, but this U shape here is called a parabola. And all quadratic functions have a similar type of shape here. An absolute value function, you all have seen absolute values before. We just haven't talked about them in this class. An absolute value function is any function where our variable is inside absolute value signs. So for instance, we could have f of x equals, and then these vertical lines right here, those are our absolute value signs right there. Now remind me, thinking back to Algebra 1, thinking back to middle school, what do absolute value signs do? They make anything inside positive, yes. And that's going to be important when if we are plugging numbers in to what we have. But for our graph, it makes a specific shape. Normally, an x by itself would be a straight line, but an x inside of an absolute value makes a V shape. So for instance, be going this way. So we have a straight line going one direction, and then we have a straight line going the other direction and making a V right there. So notice it is related to the quadratic graph. It's related to the parabola in the fact that we have lines going up on both sides, and we have this point down here at the bottom, and that point is specifically called the vertex, and we'll talk more about that in the next unit. But they have shapes that are relatively similar here. The difference, though, is an absolute value has straight lines and a quadratic has curved lines. A quadratic is a U shape and the absolute value is a V shape. All right, so let's take a look at what our problems are actually like here. So previously, we were given something that looked like this. Let's say that I have f of x. Oh, no. Getting ahead of myself. Let's say that I had this. Let's say I had 2f of negative x plus 5, like that. What transformations would we say that we have here? Yep, what's going on with it? Okay, so we start with we say we're stretched by a factor of 2. What else? Not the x-axis, the y-axis, yep. And then what about that 5 there? Right, our graph is going to move to the left 5 spaces. So we were able to identify all 3 of these transformations based on this right here. Thank you so much for helping me out with that. The way problems are going to be presented today is going to be very similar, but we're going to be talking specifically about quadratic functions and absolute value functions, which means rather than presenting the problem like this, the problem is going to be written slightly differently. So with a quadratic, I could write the same thing, but written slightly differently. So f of x on the left side is just going to be f of x. But on the right side, I'm going to have 2 parentheses negative x plus 5 squared. So notice the similarities here. We have a 2 in front of the f here, and we have a 2 in front of the parentheses down here. Those both represent a stretch. Similarly, inside the parentheses up here, I have a minus sign, and inside the parentheses down here, I also have a minus sign. Those both represent a reflection across the y-axis. And lastly, if I have a plus 5 inside the parentheses right here, and a plus 5 inside the parentheses right here, those both represent the graph moving to the left 5 spaces. So even though This quadratic function is written a little bit differently than what I started with originally and what we have been working with. These still represent the exact same transformations, and they are relatively in the same place that they were with what we have been working with. Does that make sense for the moment? Now, similarly, I could do the same thing with an absolute value function. So I could write out f of x equals 2, an absolute value sign, negative x plus 5 with another absolute value sign right here. So once again, we see that these numbers and these negative signs are relatively in the same position that they were on the original problem right here. I still have this plus 5 on the end. I still have this 2 out front. And I still have the same negative sign in front of this x right here. In fact, for all of these, this description is going to be the same. For all of these, we say that it's stretched by a factor of 2. There's a reflection on the y-axis because of the negative sign in front of the x, and the graph moves to the left 5 spaces. So for all of these, we have the same transformations, we have the same description here. So let's, once again, we're going to be asked to name all transformations. And this time, I'm going to write out f of x equals negative parentheses x minus 4 squared plus 3. So, similar to what we had seen previously, I have to describe each of these numbers and each of these negative signs that I see in this problem right here. This is similar to saying negative f of x minus 4 plus 3. Notice here we've got a negative sign in front of the f, similar to the negative sign in front of the parentheses. We've got a minus 4 inside these parentheses, and we have a minus 4 inside these parentheses, and we have a plus 3 on the end, similar to the plus 3 on the end right here. These represent the same transformations, but this one here is written as a quadratic equation. And that's going to be a format that we want to make sure that we are getting comfortable with, because the next unit is all quadratic equations. So we need to name all of our transformations. What does this negative sign in front of the parentheses do? Or what does this negative sign in front of the f do? If we have a negative sign in front of this f, similar to what we saw on Friday, it's going to be a reflection on the x-axis. And if we have a negative sign in front of this parentheses, that also represents a reflection on the x-axis. Now, what about this -4 that's inside the parentheses? What is that going to do to our graph? It's going to move it to the right 4 spaces. Remember, anytime we have addition or subtraction inside of our parentheses, that means we are moving to the left or to the right. And then what about this +3 that's on the end right here? What would that do to our graph? It would make it go up. Let's look at a new example here. Once again, we're going to be asked to name all transformations. So here we'll have f of x equals 3/4 absolute value of x plus 1 minus 5. So we have absolute value signs. This is an absolute value function, but we are still working this similarly to what we had seen before. We want to make sure that we say what the 3/4 does. We want to make sure that we describe what the +1 does. And we want to make sure that we describe what the -5 does. We don't see any negative signs in front of the absolute value. We don't see any negative sign in front of the x. So we know that we don't have any reflections, but we are going to have 3 transformations based on these numbers here. If we were to rewrite this similarly to what we had seen before, this would be the same thing as 3/4 f of x plus 1 minus 5. So for starters, this 3/4 right here, we know that a number in front of our f is either going to be a stretch or it's going to be a compression. In this case, what do we have? Is this 3/4 going to be called a stretch, or is it going to be called a compression here? And why is it a compression? So we've got a number that's between 0 and 1. We've got a denominator that's bigger than our numerator here. So because it's a fraction between 0 and 1, we can call this a compression. So we can say the graph is compressed by a factor of 3/4. We've got a +1 inside the absolute value, similar to the +1 that we have inside the parentheses right here. We know that that's going to move us left or right. And if it's plus, it will move us 1 space to the left. And lastly, we see this -5 outside of the absolute value, similar to the -5 outside of the parentheses over here. And so that -5, where is that going to move our graph? Very first transformation we learned about. It's going to move us down. So if we color coordinate that, oops, that's not what I wanted to do. Well, now the words are blue. So similarly to what we have seen, absolute value functions have numbers in similar positions to the functions that we had been working with. The only difference here is I've got some absolute value symbols rather than these parentheses, and our f of x is on the left side rather than being the only thing we see there. All right, so let's go ahead and let's do two problems for you here. I don't know. So problem number one, let's make f of x equals negative 2 absolute value of x squared plus 12. Problem number two, f of x equals absolute value of negative x plus 6 minus 14. So two problems for you to go ahead and try out. All right, so with this first one, we actually have three different transformations here, even though we only see two numbers, because one transformation comes from just the negative sign. Another transformation comes from the 2 that's in front of the parentheses. And the last transformation comes from the plus 12 right here. If we were to rewrite this similarly to what we had seen before, this would be the same thing as negative 2 f of x plus 12, like that. Oh, it's... So if we describe these transformations, this negative sign in front of the 2, this negative sign in front of an f would cause a reflection across the x-axis. The 2, since the 2 is bigger than 1, would cause a stretch. And the plus 12 on the end is going to move our graph up 12 spaces. So some color coordination between the numbers and the expressions. Oh, good job, me. There we go. So notice once again that all of our numbers on the original problem are in similar positions to the numbers that I rewrote here. The negative 2 is in front of this parentheses. The negative 2 is in front of the f. The plus 12 is outside the parentheses on the end. The plus 12 is outside the parentheses on the end right here. They're in very similar positions in the quadratic function, as well as the function similar to what we had seen previously. Down here, we've got similar things. I've got a negative sign. I have a +6 inside the absolute value, and I have a -14 outside the absolute value. So the negative in front of the x right here, if we rewrite this, this would be similar to having f of -x inside the parentheses with a +6 inside the parentheses. Because notice, whatever I have inside this absolute value is the same as inside of this parentheses over here. Those are exactly the same. Whatever I have inside this absolute value is what's inside the parentheses. Whatever I have inside these parentheses squared is what I have inside this parentheses here. We still have the -14 outside of our absolute value on the end, which means I'm going to have a -14 outside my parentheses on the end here. So we can describe our transformations similarly as the other problems we've been doing. This negative in front of the x is going to cause a reflection, but since it's inside the absolute value, it's going to be a reflection across the y-axis. The +6 will move our graph side to side. Similarly, as +6 inside these parentheses would move our graph side to side. And just like before, this +6 will move our graph 6 spaces to the left. And the -14 that's outside the absolute value will move our graph down 14 spaces. All right, let's do another set of practice problems here. But are there any questions on these two before we take a look at the next ones? All right. All right, so the two transformations we have, we see that there's a 3 in front of the absolute value sign here. We also see that there is a -4 inside the absolute value. So this time I'm not even going to write the additional way of writing this, similar to what we have before. I'm just going to work off this absolute value here. So the 3 in front of the absolute value, that's going to stretch our graph by a factor of 3. And if I have a -4 inside the absolute value sign, similar to inside parentheses previously, is that going to move us side to side, or is that going to move us up and down? -4, where's that going to move our graph? It's going to move us to the right. On this last example here, we see that there are 3 transformations. The 1/2 provides 1 transformation. The negative here provides another transformation. And then lastly, the +5 also provides 1 transformation. So if we describe these, the 1/2 in front is going to compress our graph, because that is between 0 and 1. 1/2 is between 0 and 1. The negative sign in front of the x will reflect us across the y-axis. And the +5 will move us up 5 spaces, because that's outside of the parentheses. That is going to move us up or down. Any number that's added or subtracted outside the parentheses will move us up or down. So we have our 3 transformations here that we have just described.